Done, Pooja. Okay, then we have multiple bond. Multiple bond can be p pi multiple bond, p pi d pi multiple bond. We have done in 11th class also. P pi multiple bond when pi bond is formed by p orbitals. When pi bond is formed by p orbital. When pi bond is formed by p orbital, it is p pi multiple bond. Then p pi d pi multiple bond. P pi d pi multiple bond. When pi bond is formed by p and d orbital. Understood? P pi multiple bond is formed by atoms having small size and high electronegativity. P pi multiple bond is formed by atoms having high electronegativity and small size. High electronegativity and small size. Hence, nitrogen can form p pi multiple bond, while other elements forms p pi d pi multiple bond. Because nitrogen has small size and high electronegativity. Nitrogen has small size and high electronegativity. Nitrogen exists as N2. Understood? Question based on that can be why nitrogen exists as N2 and phosphorus exists as P4 solid. Why nitrogen exists as N2 and phosphorus exists as P4 solid. Why nitrogen exists as N2 and phosphorus exists as P4 solid. So reason will be nitrogen can have this question. Nitrogen is inert and less reactive at room temperature. The question can be this also. Nitrogen is inert at room temperature. Answer will be nitrogen can form p pi multiple bond, hence exists as n triple bond n. Very high energy is required to break N2 into atoms. Hence, it is inert at room temperature. Hence, it is inert at room temperature. Nitrogen is inert at room temperature. It is less reactive at room temperature. Why? Because nitrogen can form p pi multiple bond. So it can exist as n triple bond n. Very high energy is required to break N2 into atom. Understood?
Yes, sir.
Any doubt till here? This much we have done in the last class. There is highlight also. In that half an hour. Then we have to read about the compounds. Hydrides of 15th group. General formula will be MH3. General formula will be MH3. First, we talk about basicity. What do we mean by basicity? tendency of a molecule to donate the lone pair of electron to some deficient atom or molecule to some deficient atom or molecule. Tendency of a molecule to donate the lone pair of electron to some deficient atom or molecule. So basicity is directly proportional to electron density. Basicity is directly proportional to electron density, or you can say electron per unit size. Among these compounds, all of them have only one pair of electrons. So electron is same. Now it is inversely proportional to size. We know as you download size increases, this is maximum basic, this is minimum basic. Basicity decreases down the road. Basicity decreases down the road. Understood. Understood. This is an important thing. All of you understood the trend of basicity. All of you understood the trend of basicity. For the hydrides only, for the hydrides only, if we see reducing character, reducing character, it depends upon depends upon the strength. It depends upon the strength of MH bond. It depends upon the strength of MH bond. Reducing character is inversely proportional to the bond strength of MH. Weaker the bond, it can easily give its hydrogen, and that hydrogen will act as the reducing agent. Weaker the bond, it can easily give hydrogen. That hydrogen will act as reducing agent. Okay. So which will be maximum reducing? Which will be maximum reducing? MH bond strength. MH bond strength decreases down the road. MH bond strength decreases down the road. So reducing character increases down the road. Increases down the group. Voice is cracking. What about others? Voice is cracking. Should I rejoin? No, now you have to rejoin. Copy it fast. So reducing character increases down the group. Reducing character increases down the group. Any doubt in reducing character? The chapter is all about the information. You have to remember all these informations only. Done. Can we go to next property? And on boiling point. Boiling point. Boiling point of molecule depends upon the strength of intermolecular forces. Boiling point of molecule depends upon the strength of intermolecular forces. Intermolecular forces is directly proportional to boiling point of molecule. Boiling point of molecule. Intermolecular forces are directly proportional to the boiling point of molecule. Understood. What you can say about the molecules? Which one has maximum intermolecular forces? Which one has maximum intermolecular forces? They have van der Waals forces. They have van der Waals forces. Van der Waals forces. They have van der Waals forces. Van der Waals forces is directly proportional to the size of molecule. And this particularly have hydrogen bonding. Have hydrogen bonding. What do you want to see, Nadia? Please take a screenshot if possible. Yeah. So ammonia has hydrogen bonding, while all others have van der Waals forces. Van der Waals forces depends upon the size. So this has maximum van der Waals force. This has minimum van der Waals force. Any doubt in this? Any doubt in this? Experimentally determined order is experimentally observed observed order is pH3, ASH3, NH3, SBH3, and BIH3. Understood? Because of hydrogen bonding, it is greater than the other two. Because of hydrogen bonding, ammonia is greater than these two. Weak van der Waals forces, strong van der Waals forces. Understood? 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 Okay. The question can be which among the following hydrides have are least volatile and most volatile. Least volatile and most volatile. Least volatile and most volatile. Volatile behavior is volatility is inversely proportional to boiling point. Volatile behavior, that is volatility, is inversely proportional to boiling point. So least volatile is pH3 and most volatile is sorry. Least is BiH3 and most is pH3. Understood? Understood. Any doubt in this? Okay. Thermal stability. That is stable in presence of heat. Thermal stability is directly proportional to the strength of MH bond. Okay, more the strength of bond, more it will be stable. So we can say NH3, PH3, ASH3, SPH3, VIH3. Okay, this SB is antimony. You should know that. It is coming from stilbium. It is coming from stilbium. Its Latin name is stilbium. Understood. Understood thermostability. Copy it fast. And all of you, we have bond angle. Bond angle. Bond angle. Bond angle. Okay. We know if the electronegativity of element is greater than hydrogen, bond angle will increase. Bond angle will increase due to bond pair bond pair repulsion. Due to bond pair repulsion. If electronegativity of metal is greater than hydrogen or element is greater than hydrogen, bond angle will increase due to bond pair repulsion. Understood? So bond angle should be like this, right? This is 107 degree nearly. The rest of other molecules have bond angle bond angle closer to 90 degree. Rest all other molecules have bond angle closer to 90 degree. Rest all other molecules have bond angle closer to 90 degree. Copy fast. This is according to Drago's rule. Drago's rule. It says elements from third period onwards onwards do not undergo hybridization. Do not undergo hybridization. Hence, all three p orbitals, all three p orbitals remains perpendicular to each other. Remains perpendicular to each other. Hence, bond angle is similar or nearly 90 degree in all the cases. This is a very important observation. Please copy it. This is an important observation. Please copy it. It is not just decreasing. It is decreasing and it is closer to 90 degree. So why it is closer to 90 degree? Because of Drago's rule. Drago's rule says that if third period onwards elements reacts with hydrogen, they do not undergo hybridization. They remain unhybrid orbitals. And hence p orbitals remains perpendicular to each other. Bond angle remains as 90 degree. Understood? With hydrogen. With hydrogen. Third period elements converse with hydrogen. Do not undergo hybridization, hence of the orbitals remains perpendicular to each other. Bond angle is near to 90 degree. Understood? Among ammonia and NH4 plus, bond angle and basicity. Which will have more bond angle, which will have more basicity? Any doubt? Yes. S4 plus more basicity. How? See, if we talk about bond angle, see, this is tetrahedral, 109 degree. This is pyramidal. Pyramidal, 107 degree. Because of lone pair, bond pair repulsion. Because of lone pair, bond pair repulsion. Lone pair, bond pair repulsion. Understood? Understood? Bond angle understood, both of all of you? Bond angle. Now, basicity. Basicity. Ammonia has extra pair of electron. Extra pair of electron. So, can be donated easily. Can be donated easily to any deficient species. But ammonium does not have any extra pair of electron. Hence, less basic. Understood? Sahil, Ved, Panish. Any problem to anyone in this question? Okay. Write down halides of 15th group. Halides of 15th group. They can show or they can form two types of halides. They can form two types of halides. That is MX3 and MX5. They can form two types of halides, that is MX3 and MX5. Okay, nitrogen does not form NX5. Why? Nitrogen does not form NX5. Why?
It remains a cluster of solutions. So,
Because covalency of nitrogen is 4, and that because of no vacant d orbital. No vacant d orbital. Right? Okay. Nitrogen dioxide ion. Nitrogen from NX3. Nitrogen forms NX3. Copy it first. Then except NF3, all are unstable. Except NF3, all are unstable. Except NF3, all are unstable. Why? Due to low polarity of bond, low polarity of bond, large difference in size, large difference in size of two atoms. So NCl3, NBr3, Ni3 unstable. Reason are these. Understood? Understood. So now we have some reactions. Hydrolysis of chlorides, chlorides of 15th group. 15th group. So for Ni3, Pajan rule is not followed. What do you mean by that, Sandro? Pajan rule is just the comparison of covalent nature. Okay, we cannot give any statement for a particular compound. It is the comparison for the covalent nature. Hydrolysis of fluorides of 15th group. These reactions are important, you have to remember them. Hydrolysis means adding water. Okay. In this will be negative, this will be positive. Here hydrogen is positive, OH is negative. So we will get NH3 plus HOCl. Understood this reaction? H positive, OH negative. Phosphorus less electronegative, fluorine is more electronegative. So H3PO3 plus 3HCl. You do not need to remember this reaction, okay? You can just put the charges, you will get the answer. Similarly, H3ASO3 plus 3HCl. H plus OH minus. Plus will react with minus, minus will react with plus. Understood? Now for these two, we have to remove 2 HCl. 2 HCl will be left with hypochlorite. 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 Bismuth hypochlorite. These reactions are important. All 5 reactions are important. Understood? Yes, it will have more bond angle. H4 plus. I think this small message has come late. All of you written these reactions? All of you understood these reactions? Phosphorus forms pentahalide. Pentahalide. That is PCl5, PBr5. PCl5. It has trigonal bipyramidal structure. Bipyramidal structure. Geometry. We know this. This is chlorine, this is chlorine, this is chlorine, this is chlorine, this is chlorine. These are equatorial positions. Equatorial position. These are axial positions. Axial position. Of it first. Hybridization is sp3d. For this part, hybridization is sp2. And for this thing, hybridization is pd. Understood? The trigonal plane has hybridization of sp2. The axial bonds have hybridization of pd. This all is important. And axial bonds are longer than equatorial bonds. Axial bonds are longer than equatorial bonds. Hence, they are weak. And hence they are weak. So on slight heating, PCl5 gives PCl3 plus Cl2. Understood? All of you understood this? Whatever I'm giving you, that all are questions only. PCl5 exists as ionic compound in solid state. So it has two forms, octahedral and tetrahedral. Octahedral and tetrahedral. Understood. Any doubt in this? The Br5 in solid state exists like this. There is also ionic form, but in this form. So we have to remember this as well. Understood. Understood. Another important reaction, hydrolysis of PCl5. PCl5 plus water gives POCl3 plus 2HCl. POCl3 plus water gives H3PO4 plus POCl3 plus HCl. Understood. Overall, this get cancelled out. PCl5 plus water gives H3PO4 plus 3HCl. ये 3 हो जाएगा, ये भी 3 हो जाएगा, तो ये 5 हो जाएगा. Okay, this will become 4. This is the final reaction of it. This is an important reaction. PCl5 changes to H3PO4 in 2 steps. Understood. This is an important reaction. Yes, it's 5 exchange only. All of you understood? ठीक है अब ऑक्साइड देखते हैं ऑक्साइड्स ऑफ नाइट्रोजन oxides of nitrogen. Nitrogen forms N2O, NO, N2O3, N2O4, N2O5. We should know their structures. We should know their structures. This is neutral. This is neutral, acidic, acidic, acidic. Hop it fast. We know this is laughing gas. This is called sesquioxide. Sesquioxide. This is called mixed oxide. These are some important terms. It is a 3-electron donor. The question can come on any one of them. Which one is mixed oxide? Which is sesquioxide? Which is 3-electron donor? Which is laughing gas? Okay. Now, N2O is like this. This is its Lewis dot structure. NO. Because of this, it is a 3-electron donor. 3-electron donor. We have done this in the coordination compound. Okay. Anything can be asked from these structures. You should know these structures. N2O3. N2O3. It contains at minus 30 degrees centigrade and become super cooled liquid. Super cooled liquid, N2O3, sesquioxide. This is all information you should have because these all terms can be in the question, in the form of question. N2O4. N2O4 is important. It is the dimer. It is the dimer of NO2. Which is a brown colored gas. Brown colored gas. Which is a brown colored gas. And an odd electron species. Odd electron species. Okay. This is also an odd electron species. As you can see, there are 3 electrons. So because of the presence of odd electron, it gets dimerizes. This is NO2 with odd electron. Dimerizes means 2 such molecules joins and gives N2O4. So this is N2O4. Copy it fast.
सर NO डाइमराइज होता है
NO2. NO नहीं होता. Highly unstable species to form if it get dimerized. So N2 get oxidized to form NO. NO get oxidized to form NO2 and NO2 dimerizes to give N2O4. Electric spark we provide. N2 gets converted to NO. NO get oxidizes to 2NO2 and 2NO2 gives N2O4. Understood. Now we have N2O5. N2O5 is like N2O, but it has one pyro linkage. It is an ionic compound, and ionic compound can give NO2 plus, NO3 minus. Minus plus. Copy it fast. Okay. Acetic oxides on hydrolysis provides acids with same oxidation state on central atom. On central atom. Okay. Let me know when you're done, Risaya. Done? So if we have N2O3 plus water, it will give HNO2 plus 3 plus 3. N2O5 plus water gives HNO3 plus 5 plus 5. Understood? So if you remove water from this, if you take two molecules of this and remove water from it, you will get this. If you take two molecules of this and remove water from it, you will get this. So we can say it is anhydride, anhydride of nitrous acid, nitrous acid, anhydride of nitrous acid. This can be called as anhydride of nitric acid. Understood? But we do not have any particular acid for this N2O4 because we do not have the acid of hydrogen with plus 4 oxidation state. So it gives both of the acids. It gives both of the acids. Average will be 4. So this is the anhydride of this mixture. Anhydride of this mixture. Anhydride of this mixture. Hence it is called mixed anhydride. Mixed anhydride. Mixed anhydride. Understood. Understood. So question can easily be framed on this. ठीक है, अब देखते हैं कंपाउंड्स ऑफ नाइट्रोजन. Compounds of nitrogen. Compounds of nitrogen. What all compounds we have? N2, that is dinitrogen. NH3, that is ammonia. HNO3, nitric acid. Copy it first. We have to read about them and their properties. Done. Dinitrogen. It is prepared by the thermal decomposition. Thermal decomposition. Like for example, if you have ammonium nitrite, which is prepared from ammonium chloride and sodium nitrite. अगर आप इसको हीट करके इसमें से वाटर निकाल देते हो, then you will get this. This is how we can prepare nitrogen gas. But instead of this, if you take ammonium nitrate, then you won't get nitrogen gas. Then you will get nitric oxide. Okay, you will get nitric oxide. So we have to heat ammonium nitrite, not nitrate. Ammonium nitrite, nitrate. If you heat it, you have to remove water only. If you take dichromate, ammonium dichromate, and you heat it only, we know we have to remove water. So we'll get Cr2O3 plus water and N2. So with this also we can prepare nitrogen gas. These reactions are very much important, Sneha. What all reactions I'm giving, they are very much important reactions. Ultra pure, ultra pure nitrogen is prepared by barium nitride, by barium nitride. Ba3N2. अल्ट्रा प्योर, क्वेश्चन में ऐसे दिया होगा, वेरी प्योर नाइट्रोजन इज प्रिपेयर्ड बाय बेरियम नाइट्राइड. So here this is the keyword. Understood. Structure, two pi bonds, p pi multiple bond. One sigma bond. Okay. N2 is inert at room temperature because very high energy is required to break these three bonds. N2 is inert at room temperature, has very high energy is required to break these three bonds. Understood? अभी इतना करते हैं, बाकी नेक्स्ट राउंड करेंगे. Okay, so that's it for today.